Hello everyone, this is Gyujin-jo and I'm gonna talk about phase diagram and thermodynamic modeling of zirconium chloride and MCl system. In this study, M is equal to the sodium or chloride. Since uranium fission produced zirconium, which is then present in the sodium chloride or potassium chloride solvent used as medium, research on this system is required. However, the phase diagrams and thermodynamic properties of zirconium chloride and MCl system have not been modeled. Therefore, these studies aim to model the phase diagram of zirconium chloride and MCl system by adjusting Gibbs energy of each composition. There are a few experimental research which represent phase diagrams and vapor pressure following each composition. There is not any direct data about thermodynamic properties of M2Z6 compound, so partial pressure of the zirconium chloride is used to decide enthalpy and entropy of compound. In this study, we used FactSage to match model and experiment data. Before starting modeling, we collected data and compared them. Look at the literature review part, please. Left diagram represents phase diagram data of each system. Those of data were decided by cooling curve experiment or vapor pressure measurement. Right diagram represents vapor pressure of zirconium chloride on molten salt mixture. Inflection points mean phase boundary, which is the point changing reaction enthalpy. Following Kippur-Ross, vapor pressure of zirconium on overall composition is predicted. You can see that if you rotate the left diagram 45 degrees counterclockwise, it overlaps with the right diagram. This is because all the lines shown in both diagrams represent the boundaries of the phase. Let me talk about model optimization process. To make thermodynamic model of binary system, interaction between two components should be considered. In this study, modified quasi-chemical model was used. Gibbs free energy of solution mixture is decided by modeling parameter. The present study aims to decide correct parameters able to match with experiment data. However, measurement of enthalpy and entropy of compound has never been done. We tried to decide them using equilibrium calculation of FactSage, which help us match vapor pressure with data. Look at the optimization result part, please. The graphs illustrate the relationship between log pressure and 1 over T. The lines are pressure of model and dots of experiment data of flame gas. According to Clausius equation, the slopes of those plots correspond to the enthalpy of the process. The vapor pressure can be converted to activity of zirconium chloride on compound and solution. When we adjust enthalpy and entropy of compound, slope is modified as well. Also, interaction parameter affects Gibbs energy of solution and slope as well. The overlaps between models and experiment data mean models match experiment data. The models contain enthalpy and entropy of compound and interaction parameter of modified quasi-chemical model. In conclusion, in this study, the thermodynamic assessment of two binary systems were carried out. The available phase diagram data and extensive vapor pressure data of zirconium chloride in these systems were carefully examined to obtain the accurate Gibbs energy. Overall phase diagrams and vapor pressure data of zirconium chloride are well reproduced by the present thermodynamic model with optimized parameters. Thank you for listening.